Here we're looking at an engineering scale. Engineering scales have a number 10, 20, 30, 40, 50 next to them, and they indicate how many tick marks have been divided into an actual inch. So here we have the 10 and the 50 scale for engineering. With the 10 scale, you'll see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tick marks that are measured or divided within 1 actual inch. The scale above, we have 50 tick marks between the 0 and where the actual inch mark is. So we can see that we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tick marks here. There's 20, 30, 40, and a total of 50. Because of the nature of these scales, they can be used for a variety of different scales, as long as the number that you see in the second or the scale or the number on the right begins with the same number that you're using for that scale. So here are some examples for the 10 engineering scale. This scale could be used for 1 to 1. So this is 1 inch. This is 1.1 inches and so on. Or it could be used as 1 to 10. So that means 1 inch is equal to 10 inches. We just simply add a 0 to the end of this number. So this would be 10 inches. This would be 11. This would be 20. Or it could be used as 1 inch equals 100 inches. So this would be now 100, 110, 120, so on, 200. Or it can be used in a civil application where 1 inch is equal to 10 feet. So this is a 10 feet rather than 10 inches now. So this would be 10 feet, 20 feet, 21 feet, 22 feet, and so on. Or I could keep going and add another 0. This could be 1 inch equals 100 feet, 1 inch equals 1,000 feet, and so on. The scale itself cannot really be read without knowing the scale of the drawing. So we'd look at the scale of the drawing and see what it says, and then we'd know how to treat that number. So let's imagine that we're using this 1 inch equals 10 foot scale and read the scale. So if it's 1 inch equals 10 feet, then I know this 1 inch here is equal to 10 feet. This is 20 feet, that's 25 feet, 26, 27 feet. So I would write this out as just 27 feet. If I wanted to show at least one decimal place for precision, I can also write that out as 27.0 feet. If we're using the scale as 1 inch equals 100 feet, now I know this is 100 feet, then that means this is 200 feet. So this is 400 feet. This would be 450 feet, 60, 70. So it would be 470 feet if I was using 1 inch equals 100 feet rather than 1 inch equals 10 feet. So 470 feet. As these values go up on the right hand side, our precision would get less. So this would never be, or it would be unlikely this would be to a decimal place like this one would be. So this would be 470 feet most likely, and you would put in a decimal. So this last one, let's imagine that this is 1 inch equals 10 inches. And what would it be? So if we were using this scale as 1 to 10, or 1 inch is equal to 10 inches, then this would be 80 inches, this would be 85 inches, and then we'd have to add 3 more to make it 88 inches. So see how we've read this scale 1, 2, 3 different ways, all dependent on which scale here we've decided to use it as. Numbers remain the same, but the number of zeros or decimal places, positions will change depending on which scale we use here. Every single one of the engineering scales is exactly the same way.